Okay, good evening, everybody. And this is Professor Ayorinde welcoming you to the first class session of the fall 2012 Organic 1 session. I will be your guide for the rest of this semester. We are going to start, of course, organic chemistry, which is almost like going through a journey. And you and I will be going through this journey together. And of course, it is going to be a very interesting journey indeed. During the course of traveling, we will be learning a lot about organic chemistry, organic molecules, and all kinds of study or all kinds of information about the chemistry of organic compounds. But before we go into the lecture for today, which is chapter 1 of your book, what I want to do now is go through some of the administrative details for how are we going to administer this class session during the course of this semester. I'm sure some of you have already seen the syllabus. Let me bring that up again. Okay, how many of you have seen this syllabus? Okay, very good. So all of you have seen this syllabus. Okay, just for the benefit of all of you, since this session is being recorded, so I thought I should bring this up again. Of course, the book we are using, the textbook is McMurray, you see this right here, which is the 8th edition. I'm hoping every one of you has a copy of that already. Also, the solution manual of McMurray we are going to be using. In addition to that, we are going to use the online web learning software that comes with the book. Okay, this is the acronym for that is OWL. See right here. You see it? Okay, see my cursor? Okay. Also, as I informed you earlier, there will be occasional live online problem-solving session. This online problem-solving session will be on Wednesdays, unless there is a reason for us to change to another day. But for now, it will be on Wednesday at 8 p.m. What I will do, I will send each one of you the link to that session. Once I send you the link, just keep that link. That will be the link we are going to use for the rest of the semester. In as much as possible, I will encourage all of you to be part of this session. Of course, since this session will be recorded also, those of you who, for whatever reason, cannot make it, the recording of the session will also be posted in Blackboard. Okay. Of course, we encourage that you have molecular models. It helps when we when we do stereochemistry, for you to have access to molecular models, so you could see molecules in 3 dimensions. The prerequisite for this class, General Chemistry 1 and 2. I'm assuming that each one of you has taken General Chemistry 1 and 2. Okay. So if you have not, then you should not be in this class. Okay, I will leave you to take a look at the course objectives at your own time. Okay, at the end of this course, these are all of the things that you should be able to do. Indeed, I will advise that you come to this syllabus each time and go through this and ask yourself, am I able to do any of these, perform any of these functions here, or do I know any of these concepts that are listed here? Okay, so if you say no, then that means you either have to study some more, you come and see me. And by the way, my office is room G15. G15, this is in the chemistry building. I should also let you guys know that I am retired. I used to be the head of the chairman of the Department of Chemistry for the last 5 years. But at this point, I'm retired, so I just work part-time. I do not come in on Fridays, but I come in on Monday, Tuesday, Wednesday, Thursday, and I come in the afternoon. So in addition to my office hours, the office hours listed here, right here, 1:30 to 3:30, on Tuesdays and Thursdays. In addition to those office hours, please feel free to come and see me at any time on Monday, Tuesday, Wednesday, and Thursday, anytime after 2 p.m. Okay, I will always be around. Just in case you cannot see me during the office hours, which is Tuesday and Thursday at 1:30 to 3:30. Do not feel that those are the only times that you can see me. It is very important that if you are having problem earlier on in the course, you need to begin to dialogue with me so we know what the problem is, how do we solve this problem. Do not wait until the end of the semester, then it's too late. Okay? Okay, in terms of the assessment, how do we assess your performance in the class? We have several quizzes. These quizzes will be given both in class and online. Generally, there will be about 10 to 15 minutes in the face-to-face session, just like this. And this quiz could be any time you come in. Okay, so this is one form of assessment. That also allows me to see how much you actually know, so I know where to put all of my emphasis in terms of going forward on a particular topic. So we are going to have several quizzes. As you can see, each in-class quiz is 12 points, and the online quiz is 5 points. The maximum you can score for the online quiz is 40 points, and the maximum you can score for the in-class quiz is, depending on how many we take, it could be about 10, maybe 120 points or whatever. But the combination of both online quiz and in-class quiz, you have a maximum of 100 points that will be used to compute your final grade. Which is to say that I will be dropping some of the quizzes. Even though we are going to take several quizzes, I will be dropping some of them. By the way, if you have any questions, feel free to ask me. Okay? Yes?
Are you going to drop, are you going to tell us how much you're going to drop, or are you just going to drop the lowest quiz?
Yes, I will drop the lowest quiz. Say, for example, if we end up taking 10 quizzes, okay? And then the 100 points for your quiz, they could come from those 10 quizzes if you want, because I could drop about 2 of them, so that gets you close to 96 points, which would be close to 100 points. So you could actually make all of your quiz points from the in-class quizzes, okay, or a combination of the in-class quiz and the online quiz. But I will be dropping the lowest. Okay. Of course, we do have points for class participation. This is essentially encouraging each one of you to be part of this class session, both the face-to-face session and the online session. Asking questions, responding to questions, helping us to solve problems when we are doing problem solving. In other words, we do want you to be part of this class session. It isn't just for me to simply recite the content for you, but it is for you to actually interact with me so that there will be an ongoing conversation between you and I, and also within the class. That is one of the best ways to actually learn, by engaging yourself in an active learning process. Okay, so there is class participation. Okay, all of this information, of course, they are contained in the syllabus, so I would advise that you read the syllabus in detail. We are going to have 4 class exams. and each one of them will be worth 150 points. And I will drop one of those exams, which is to say that I will not give any make-up exam. If you miss an exam, I will simply use one of those to make up the exam that you miss. At the end of the semester, there will be two types of comprehensive exams. One I call the ACS type comprehensive exam, which is on the same day that you have departmental exam across the campus. It is 400 points. Also, a couple of days later, we have a similar comprehensive exam. This will be the final exam. Now, you could use any one of these. My advice is, if you take the ACS type exam and you do well, you could also take the final exam. You do well, I will take the better exam. You know, whatever the lowest one, I will drop. Okay, so that gives you a chance to actually, try the comprehensive exam with the ACS, and then if you do well, you probably don't need to take the final exam. That is your choice. You have to make that decision. So there are plenty of opportunities for you to actually bring up your grade at the end of the semester. Okay, here I also indicated here how the OWL, that is the online quizzes, will be the points will be assigned. So we want to take a look at that also. Okay, assignment of letter grades. The letter grade A, B, C, D, hopefully no F in this class at the end of the semester. The letter grades will be assigned based on the highest performance in the class out of a total of 1,000 points. Okay, so you will be competing with one of your colleagues or some of your colleagues in this class. Okay, this is the breakdown of the letter grade. Okay, I also have here the dates of the exams. We have 4 regular exams. The first exam will be September 18. Okay, does anybody know when the second exam is? October 18. How did you know that? How did you know that? That is October 18. No, I was just playing. I know. Okay. Okay, so the dates of the exams are given and the topics are also given. Then for the ACS type comprehensive exam, this will be given on December 4 at 6:30, between 6:30 to 8:30 in this room, December 4. And the final exam will be on Thursday, December 6, also in this room, from 5 p.m. to 7 p.m. Okay, those are some of the major points with regard to the syllabus. Does anybody have any questions before we move on? Yes.
Can you explain a little more in detail of the assessment of the points for, when it says like 95% of the highest score?
Mm-hmm.
Could you explain a little more?
Okay. Say for example, I say A will be 95% of the highest score. Say out of 1,000, say the highest score was 800 points. Then 95% of that will be A. Okay? 95% of the highest score will be A. Then 85% of the highest score will be B. 75% of the highest score will be C. So that is what I mean by depends on the highest. Kind of, yes. Kind of, yes. Okay. So, say for example, out of 1,000, the highest scorer was 500, right? Okay. So what would be A? Somewhere between 400 and 450, right? So 95% would be A. So it's relative to the highest score in the class. Right. So it helps. It helps if everybody score 100%, right? Does that answer your question? Does that answer your question? Okay, is that Tiffany, right? Oh, okay, good. Okay, any other question? Yes.
The Ross has that you do on Wednesday the 8 and 9.
I would advise that you should be there, but if for whatever reason you cannot, you don't have to. You don't have to be there. But for the most part, it is better for you to be there. Okay, even though the session is recorded, and I will post the webcast in Blackboard for everybody to see. But it's better to actually be there because we will be working problems, talking about working problems and discussing back and forth. It's almost like being in the classroom. Yes. That's just a minute. That's Jackson, right? Ryan Jackson. Yes. Yes, I think you could if you go to. I think you can. Yeah, it comes with the textbook, but I believe you can buy ours separately. Yes. Oh, I don't know. No. Okay, any other question? Yes. Yes. Say that again. It depends on, if you say, okay, when you buy the textbook in the bookstore, it gives you an access code. But I believe it comes also with that access code gives you access to the OWL. Oh, does it? Okay, then that's fine. Oh, I mean the solution manual? Yeah, that's your decision. Yeah, that's your decision. You can either buy the one online and use the one online, or buy the one from the bookstore. But I do believe when you buy the one from the bookstore, they come as a package. It doesn't? Oh, okay. Yes. Is that? It would. Okay, it would. Hey, folks. Yeah, go ahead. Can we have some quiet, please? Okay, go ahead.
Is the departmental final the same as final comprehensive exam?
Yes. It will be not the same exam as that, but the same type of format. The same.
Not the same exam, bro?
No, it's not the same exam. No.
So you have the choice of either choosing that, the final exam, and the ACS.
If you take the ACS exam and you feel that you've done very well, you may decide not to take the final exam because it's essentially the same thing. Okay, the reason why I have the ACS exam, I do want to use that to compare the performance of all of you against a national performance. So if you do well, you don't have to take the final exam. Even if you take the final exam and you don't do as well in the final, then I will use the one where you did better. Okay. Yes, somebody raised their hand. Yes.
Okay, so I wanted to be reiterate this, but the exam and your final is within 2 days of each other.
Yes.
You will take the higher grade.
Yes.
Both.
Yes. Yes. Okay. Any other question? Okay, very good. So now everybody is aware of the some of the major aspects of the administration of this class. But if you are still in doubt, make sure you go through the syllabus. And if after that you are still in doubt, you come and see me for additional explanation. I also told you earlier that if you go to this website, by the way, when you see the recording, this website will be there. The recording of this session, you will see this website. When you go to this website, actually I have to go back to here. Go back to here. Okay. You go back to this. Go to this website, which is www.appliedtechandsciences.com. You get to this page, to this website, and then you scroll down. You click on Organic 1, Fall 2011. All of the lectures, both the face-to-face lecture and the online lectures, are posted on this page. So you could decide to, okay, if I do that right now, if I click on that, okay, it takes me to the next page, which has all of the lectures. Okay, you have structure and bonding, bond polarity, which is chapter 2. You have chemistry of alkanes, chapter 3. You have stereochemistry, which is chapter 5. So all of those things are there. You have the whole semester of lectures and problem-solving sessions. Okay? So you could decide to watch anyone you want. And then, of course, you could also save them in your flash drive. So once you save it in your flash drive, you don't need to come back to here to watch it. You could just save everything in your flash drive, and when you go home, if you don't have access to the internet, you simply just play them without the internet. Yes?
When it comes to homework, is it only basically our quiz and assessments that we do online in class? Or are you actually finding, like, stuff out of the textbook?
Oh, I see. Okay, the question is based on the, you said the homework assignment? Yeah, the homework assignment, if I give you homework assignment, this will be based on how. It will be based on how. I will give you problem to do, every week I will tell you what the assignment will be. I will also send you email reminding you what the assignment is and what the deadline for the assignment is. This will be online. Of course, the face-to-face session, just as we are now, the quiz will be right here. Okay. So it is a combination of in-class quiz and online quizzes. Okay. Okay, so you can see here, you can see on this page, you have the review session for the final exam review. You can see right here. We actually had 2 review sessions for last fall, 2011. Okay. Any question on this? Yes.
I have a quick question in regards to hours.
No, it's different. It is different. Actually, the first session, the first online session we are going to have, which will be next Wednesday. We'll have an online session next Wednesday. What we are going to do, we will do R, so that you get a chance to actually see how to do the R, what it looks like. Okay, so that will be the first thing that we are going to do for the online session. That is next Wednesday. Okay, I will send you more information about that. Okay, any other question? Okay. Now let us now go to today's lecture, chapter 1. By the way, for the most part, you do not have to spend most of your time trying to write down the notes, because, like I said, this lecture is being recorded, and the webcast or the recording will be posted. For this session, I will post the recording tomorrow. I'll try as much as possible to post the recording within 24 hours of each lecture. Okay, so today we are going to start the journey of organic chemistry. So essentially, this first session here, we are going to just begin taking a look at chapter 1, which is taken from the 8th edition of McMurray from your book. And in this chapter, for the most part, we are going to discuss structure and bonding. You will find that most of what we are going to discuss in this chapter, you should have done in General Chemistry 1 and 2. So we are not going to spend too much time on this, since this is just sort of like a review for all of you. Okay, we start off by discussing why do we study carbon in the first place. What is unique about carbon? So we discuss the uniqueness of carbon atom. Then we go to electronic configuration of carbon and other atoms of interest to us. Go to valence, tell you what valence electrons are. I'm sure you already know about valence electrons. Discuss very briefly valence bond theory, which should be a review for all of you who took General Chemistry 1 and 2. Then we discuss hybridization. And finally, in this chapter, we'll begin to show you how to draw organic molecules, the structure of organic molecules, the various ways of drawing organic molecules, organic structures. Now, for each chapter that we discuss in class, there will also always be a page that are generally titled Outcome Objectives. This is a very useful page indeed, but what this does is to let you know those concepts that you should master at the end of each chapter. For example, at the end of this chapter, you should be able to do what? Can anybody read for me? What can you do? What are the first 3 things that you think you should be able to do at the end of this chapter? Anybody? Yes. Okay, yeah, read. Okay, in other words, at the end of this chapter, you should be able to do those things, right? You should also be able to write the ground state electronic configuration of carbon atom and other atoms at the end of this chapter. These are some of the concepts and skills that you should master if you have studied this chapter the way you should. Can somebody read for us items 5 and 6? What should you be able to do at the end of this chapter? Yes, go ahead.
Write the number of valence electrons of atoms that are relevant to this course and identify atomic orbitals containing electrons that are used for bonding.
Very good. So, in other words, all of these things you should know. So, this kind of page here does allow you to put in context what you are supposed to know at the end of this chapter. So, always come back to this page, always. Say, do I know all of these concepts? Am I able to do all of these things, these items here? If the answer is no, that means you go back and do some more studying. Okay? Lastly, we say you should be able to write molecular formulas from chemical structures. In other words, if I give you a chemical structure, supposing I write this, that is a chemical structure. If I write that, that's a chemical structure. And I say, give me the molecular formula from that structure. At the end of this chapter, you'll be able to do this. Right now, it might sound foreign to you, but you'll be able to do this. If I write this, okay, I say, give me the formula for that molecule. That is the molecule that we use to remove our paint. That's the solvent for removing paint. It's called acetone. If I say, give me the formula for that molecule, you should be able to give me the formula based on the structure. Okay, so that is what 10 is telling you. Okay, is there any question? Okay. If I give you this molecule here, which is cholesterol, at the end of this chapter, or at the end of this lecture, the chances are you should be able to give me the molecular formula. Right? Okay, this is cholesterol. So now this takes us to why is carbon unique. We told you earlier, the first thing we want to discuss the uniqueness of carbon. You will find that carbon is probably the only atom in nature that is capable of bonding it to itself to form stable molecules. For one of the few atoms or elements in nature that is capable of bonding to itself to a cell to form stable compounds. This here, this molecule we call methane. Of course, the first thing some of you should ask me is, what is organic chemistry, by the way? What is organic chemistry? Does anybody know? What is organic chemistry? Anybody want to volunteer? What is organic chemistry? What is it? Study of carbon containing. Continue. You're almost there. Okay, just like you said, organic chemistry is the study of carbon-containing compounds. The study of those compounds or molecules that contain carbon and hydrogen. That is organic chemistry. When we say we are studying organic chemistry, in other words, we are going to study the chemistry of those molecules that contain carbon atoms and very often also containing hydrogen atoms. So the study of carbon-containing compounds is what we call organic chemistry. Carbon containing compounds the study of carbon-containing compounds. That is what we call organic chemistry. And this molecule that I have on this page here, on this slide, you notice one thing they have in common is that all of these molecules here, they all contain carbon atoms. All these molecules contain carbon atoms. This here, all of these molecules here, these are the molecules that you use for cooking. You know, your cooking gas, it's a mixture of those molecules. You have methane, ethane, propane, and butane. Your cooking gas, the gas that you use for cooking at home, that is the composition. As you can see here, in the methane molecule, you only have one carbon atoms in there, bonded to what? What is that carbon bonded to? Hydrogen. Bonded to hydrogen. So, one unique feature of carbon is it is capable of bonding to other atoms to form stable molecules. Carbon is capable of bonding to other atoms to form stable molecules. In the molecule ethane, how many carbons do we have here? 2. Do we see a bond between 2 carbon atoms? Do you? You see a bond between this carbon and this carbon. Do you see that? Right? So carbon is also capable of forming a bond with itself to form stable molecules. Well, carbon is one of the few elements in nature that is capable of doing that, bonding to itself. Now in this molecule here, which we call propane, how many carbons do we have? 3. You know, notice that those 3 carbons are also bonded to, one bonded to another, another bonded to another carbon. In the butane molecule, this here, how many carbons do we have here? 4. Supposing I ask you to give me the molecular formula of that molecule, what will it be? Let's start with carbon. See what? C4, very good. And what? H10. You see how easy that is? Going from the structure to the formula. Okay? Simply just taking a look at all of the elements in that structure. And you write the formula C4H10. The carbon comes first, followed by hydrogen, and then after hydrogen, you write the other elements that are present in that molecule. Now, you also see here that in this molecule here, that we call nicotine, right here, the corner of each, the intersection of 2 lines, this line and this line, that intersection right here represents a carbon atom. Represents a carbon atom. So if I draw this, if I draw that, that represents a molecule, an organic molecule. This here, this intersection right here, what is in that? What is there? That's a carbon atom. This intersection right here, what is there? A carbon atom. Here, another carbon atom, right? Here, another carbon atom. Another carbon atom. Another carbon atom. Yes.
So it's 2 carbon atoms connected?
Yes. You know, this carbon is connected to this carbon, and this carbon is connected to this carbon. Now, you're also going to find out later that carbon needs 4 bonds. Carbon needs 4 bonds in order to form a stable molecule. So if we tell you that this carbon is bonded to this carbon and this carbon, how many bonds have we shown you so far? So when you see that, that means that the other 2 bonds that are not shown are hydrogen atoms. In other words, this is just a shortened form of doing this. Instead of doing this, doing this, doing that, doing that. So whenever you see a carbon, the intersection of two lines, you see that means a carbon atom. If you do not see any other atoms attached to that carbon, assume that those other atoms are hydrogen. Okay? Assume that they are hydrogen. So therefore, supposing I give you this molecule here, I say give me the molecular formula of that molecule. What will it be? C4, very good. C4, see I told you it's very easy. C4, H, 8, very good. You see, you thought it was difficult, right? That is the molecular formula of that molecule. This is what we call the line bond formula. In other words, you just show the lines. That is one way of representing molecules, organic molecules. Okay, let us continue with this. I was telling you about this molecule called nicotine, right here. You know, where do we find nicotine? Cigarette. Okay, this is the molecule that clogs up your lungs and causes cancer and all that. After I've said, are you going to smoke cigarettes from now? No smoking cigarette, right? It kills you, right? Okay, this is that molecule. Yes, right. Structure, yeah. Yeah, line bond structure. Okay. Okay, so this is the molecule of nicotine. Of course, you say this carbon right here, right? What is this here? Carbon. Here? Nitrogen, exactly. Okay, so you can see here, carbon is capable of forming multiple bonds to itself. Not only is carbon capable of forming single bond to itself, it is also capable of forming a double bond to itself or a triple bond to itself. Okay, and that's what you see here. So this carbon here and this carbon here, they are doubly bonded to each other. So that is another unique feature of carbon. In other words, it's one of those few elements that is capable of bonding multiply to itself in order to form a stable molecule. Here we could also see carbon is bonding to another atom, nitrogen. So carbon is capable of doing that. Okay, here we see, what do we have here in this corner here? Carbon. Bonded to nitrogen. Bonded to what is here? And what else is here? How many? 2 hydrogens, exactly. See, that easy. Okay, good. This here Valence. This have any of you heard of this molecule before, Valence? Okay. It used to be a painkiller made by Merck. That's the name of the. Have you heard of Merck company before? It's the name of the pharmaceutical company. I think they had to pay close to about $1 billion lawsuit because this is supposed to be a painkiller, but it has so many bad side effects. I think in 2004 it has to be pulled out of the market. But the point to be made there is that carbon-containing compounds could also very often have biological activities. Okay. This here, oxycontin, is also an analgesic. It is a painkiller used for fever and all that kind of stuff. Okay, so this also a pharmaceutical drug. You can see here the complexity of this molecule. Right here, what is here? What atom is here? Carbon. That carbon is bonded to what? Oxygen. And bonded to how many other carbons? 2 other carbons. So carbon is capable of bonding to several other atoms. Okay? To form complex molecules. Okay, so what we've done here to simply show you why carbon is unique. Why do we study carbon? Why do we study carbon? These are all of the reasons why we study carbon. But more importantly, because most of the carbon-containing compounds do have what we call essential biological activities. Your proteins, the protein in your body, your DNA, your nucleic acid, yes.
Question about the last slide.
Yes.
You said it was connected to 2 carbons. Can you show me? Can you
Go back. Oh, okay, good. Which one?
You said 2 carbons.
This here? This carbon here. Okay, this carbon here, right, is bonded to this carbon right here, right? It is also bonded to this carbon right here. Okay, so it's bonded to 2 carbons. In addition, it is bonded to oxygen. You also remember we told you that carbon in any stable molecule must always have 4 bonds. So therefore, the 4th bond is double. See? Okay. So that is very important going forward. You see that? Okay. Okay. Yes.
I don't. There's something about it too, and then the option is the air away from
Okay.
Oh, the other carbon.
This is 2 bonds right here. This is 1 bond right here. That's 3. And the one to oxygen is 4. You got it? You got it? Okay. Okay, very good. Okay, in the case of cholesterol, right, this carbon here is bonded to what? How many carbons? This carbon right here. This carbon right here. This that is connected to which atoms? 1 oxygen, right? And 2 carbons. Okay, this is a carbon. This is another carbon. And then it's bonded to what else? Hydrogen and oxygen. Okay. Okay, so now you guys becoming organic chemists. Your first lecture. Okay, very good. Okay, so what I've listed here, some of the unique features of organic, carbon atoms. What was the first item I said that you should be able to do after you finish this chapter? Anybody remember? Right? What is that? What is the first item that you should be able to do at the end of this chapter? Exactly. Okay. Okay, so now you should be able to do that, right? Okay, very good. Now, by the way, what time is it? 7. Oh, okay, so we got plenty of time. We should be able to finish chapter 1 today, right? We should be able to, right? You don't believe it, that we should be able to finish chapter 1 today. We should be. Okay. Now what I have here is your periodic table. And what I want to show you here, some of the elements or atoms that will be of interest to us during the course of this semester. Fortunately for you, you don't need to know about all the periodic table. You need to know about hydrogen, of course, carbon atom, right? Nitrogen, oxygen, fluorine, phosphorus, sulfur, fluorine, bromine, and iodine. Those are the major elements or atoms that we are going to find in most of the molecules of interest to us during the course of this semester. Okay, so we need to know about all of those elements. Okay, their electronic configuration, they are what we call valence electrons, their valence shells, all of those things we need to know. So anyway, as far as you are concerned, those are the most important elements or atoms that will be of interest to us during the course of this semester. Yeah, I'm not good. I don't want to waste your time or bore you in terms of telling you the history of organic chemistry, how organic chemistry evolved from the theory or the vital force theory, where people used to think that organic chemistry was the study of living molecules, or the study of anything that is derived from a living organism. That was a long time ago. That was the definition of organic chemistry in those days. So I'm going to leave this to you to read more about the evolution of organic chemistry to what we have today, and how do we define organic chemistry today? Anybody? Study? Oh, go ahead. Yes. Exactly. Today we say organic chemistry is the study of carbon-containing compounds, and some other people also want to add hydrogen. Say the study of compounds that contain carbon and hydrogen atoms. That is fine also. Okay, so I will leave this for you in terms of knowing about the history, how organic chemistry evolved from the early stages of this discipline to what we now regard as organic chemistry today. Of course, also, before we go forward, I am assuming that in your general chemistry 1 and 2, you guys already studied the atomic structure. You guys should know that every atom comprises of what? Nucleus. A nucleus, right? A nucleus. And in the nucleus, what do you have? Are the major components of the nucleus? Protons and neutrons. The protons are positively charged. The neutrons are neutral. So protons are positively charged. Neutrons, of course, are neutral. Now, surrounding the nucleus, you have what we call orbiting electrons. Electrons just moving around the vicinity of the nucleus. And these electrons simply do not just move around anywhere they want. They are specific region or space around the nucleus in which you can find the electrons. Anyway, the electrons are negatively charged. Electrons are negatively charged. But we also know that the atom itself is electrically neutral. So if we have in the nucleus, if we have the protons are positively charged, and then surrounding the nucleus, you have the electrons that are negatively charged. So what does that tell you about the number of nucleus relative to the number of electrons in an atom? What does that tell you? The same. Exactly. Very good. They must be the same, because the atom is electrically neutral. You have positive charge, negative charge. So the number of protons that you have in an atom, in the nucleus of an atom, must be the same number of electrons you have surrounding that nucleus. And what do we call the what do we call, scientific term do we use for the number of nucleus in an atom. What do we call that? What do we call that? No, let me go back. Let me see. Do I have? Let me see. Okay, let's use that. What do we call the number of protons that we have? What time do we use? Atomic number. That is going to be very, very important going forward. So what is atomic number again? Number of protons in a given atom, right? And that equals what? Number of electrons. So therefore, for oxygen atom, what is the atomic number of oxygen? 8. So what does that tell you about the number of electrons? So that 8. So oxygen has 8 electrons and 8 protons. Okay? 8 electrons and 8 protons. How about nitrogen? 7. 7, how many electrons? 7. About sulfur, fluorine. 9 electrons. Okay? So these numbers here is what we call the atomic number. All of this here. For boron, 5. Carbon, 6. Nitrogen, 7. Oxygen, 8. Fluorine, 9. Okay? Those numbers are going to be very, very important going forward. So let us go back. Okay. I told you that those electrons, they move around the nucleus in very specific spatial regions, space around the nucleus. Okay? And this very specific region in space is what we refer to as atomic orbitals. We refer to them as atomic orbitals. So those electrons that are moving around the nucleus, you will find them in those very specific regions in space, and we refer to these as atomic orbitals. Are these new to all of you here? I'm sure these are reviews, right? This is reviewed to everybody here. Very good. Okay, so we refer to those regions in space where we find the electrons. What do we call them? Electron orbitals, right? That's right. We call them orbitals. So those electrons you find in those orbitals. Now there are different types of orbitals, as you already know. We have what we call the s orbital, and the shape is spherical, right? It's round. In other words, the electron in the s orbital will simply be moving around in a circle around the nucleus. And then we have the p orbital. So electrons that you find here, something like dumbbell shape, you see it? So this would be your nucleus right here. So you have electrons are simply moving, almost like a letter H, you can see it. So we say that is what the p orbital will look like, the shape of the p orbital. Then the other orbital that is of interest to us, not so much as the s and the p orbital, what we call the d orbital. In the d orbital you have 4 lobes. In the p orbital you have 2 lobes. This is a lobe right here and this one here. In the d orbital you have 4 lobes. Fortunately, most of the atomic orbitals that will be of interest to us will be the s and those electrons will be in the s and the p orbitals during the course of this semester. Now, let us give you further information about the p orbitals. The p orbitals also have what we call directional features to them, in which you have here, I'm showing you here, 3 p orbitals. Yeah, what we call the px orbital right here. In other words, we see it's along the p orbital is along the x-axis. Right here. You see it? Everybody see it? Then you have the py orbital, which is the orbital is the direction is along the y-axis. And then we have what we call the pz orbital, where you have the direction is along the z orbital. So in the case of the p orbital, you have 3 types of p orbitals. On the other hand, how many types of s orbitals do we have? How many types of s orbital do we have? 1, because there is no directional feature to the s orbital. It's just a circle around the nucleus. But in the case of the p orbitals, you have, because of the nature of the p orbitals, you have 3 types of p orbitals, depending on their spatial orientation. You have one that is oriented in the x-axis, one oriented in the p-axis, and one oriented in the z-axis. Now, each one of these orbitals will take a maximum of 2 electrons. You will find a maximum of 2 electrons in each one of these orbitals, whether it is the s orbital or the p orbital. Okay? So in the s orbital, the maximum number of electrons that you could find in an s orbital is what? How many? S orbital. 2. Okay. But in the p orbitals, what is the maximum number of electrons you can find in the p orbitals? 6. Because you have 1 in the px, 2 in the px, 2 in the py, and 2 in the pz. So that is a maximum of 6. And that is what we want to show you here. On this slide, we now show you the different levels, the different energy levels of these 3 orbitals. Hopefully all of this is revealed to all of you. So that is why I'm kind of rushing through this. Alright, it is review, right? Okay. So what we have here is the different energy levels for all of these orbitals. They have different energy levels. Of course, the s orbital as the lowest orbital, and within a given atom, you have what we call different energy level. Here we call this the first shell. The first shell, energy shell. In that first energy shell, you only have an s orbital in there. We call that 1s orbital. Okay, this is the first energy shell. Here is the second energy shell. In the second energy shell, we also have what we call the 2s orbital, and then we now have the 2p orbitals. So you see, within the second energy shell, there's a difference in energy between the 2s orbitals and the p orbitals. So this is just a graphical representation of those orbitals. Now what do we see here? We are simply saying that the maximum number of electrons you have in the s orbital is 2. The maximum that you have in each of the p orbital is 2. 2 here, 2 here, 2 here. And then you go to the third energy shell, which is right here. In the third energy shell, now you have 3 types of orbitals. You have the s orbital, the p orbitals, and the d orbitals. Okay. In the first energy shell, you only have 1 s orbital. The second energy shell, you have two types of orbitals, the s and the p. And the third energy shell, you have s, p, and d. As you can see here, the s orbital has only 2 electrons. The p orbital has maximum of 6, because each one of them must only take 2 electrons. And the d orbitals, you have 5 of them, 5 d orbitals. Each one of these will take a maximum of 2 electrons. So therefore, what is the maximum number of electrons you could have in the d orbitals? 10. Okay. So different atoms or elements who have electrons that occupy each one of these depending on their atomic number. In other words, depending on the number of electrons they have. Okay, we've already told you, show you this periodic table here, which simply shows you the atomic numbers of most of the elements or atoms of interest to us. In this case, you have carbon, nitrogen, oxygen, phosphorus, sulfur, fluorine, and bromine. Sometimes boron. Okay, you can see here, those numbers on top, those represent the atomic number. And then what does the atomic number tell us? Number of electrons. Please do not forget that. That is very important going forward. The atomic number tells you the number of electrons that you have in a given atom. Okay, we have plenty of time. Now, let us now begin to take a closer look at each one of these atoms. Let us start with the carbon atom. Supposing I tell you to write the ground state electronic configuration of carbon. Okay? That's what it looks like. That's what it looks like. So instead of writing the graphical representation that we gave you earlier, what is the first thing we do when we want to write the ground state electronic configuration of carbon? What is the first question you ask yourself? How many electrons does it have? Then how do you know how many electrons does it have? You look at the periodic table, right? The periodic table will always be made available to you. If you look at the periodic table, what is the atomic number of carbon? 6. Okay? Yes. Okay. No, I mean, I can't hear you. Where? No, I'm sorry. Oh no, wait a minute. I'm trying to see here. This one here? No, this is carbon. Oh, if it was nitrogen. Oh no, we'll get to that. Okay, let's do this carbon first, okay? Supposing I say write the ground state electronic configuration of carbon, right? Carbon atomic number is what? Which means it has 6 electrons. Therefore, it has 6 electrons. Okay? We know the orbitals, the energy level of the orbitals. So the first orbital is what? 1s, right? So 1s. How many electrons go in the s orbital? 2. So we place 2 here. Then what is the next orbital we have to deal with in terms of the energy? 2s. Very good. So we now have 2s. How many electrons do we place there? 2. Then what is the next energy of orbital energy level? 2p. Okay. How many p's do we have? How many p's? Orbital. How many p orbitals? 3. Okay. So far, how many electrons have we used? 4. So how many electrons do we have left? 2 more, right? Do you place those 2 electrons in the 2px? What do you do? Okay, so you have 2px1, right? 2py1, right? Which means that the z orbital has no electrons, so we don't have to write it. Yes, go ahead. Yeah, at this point, I think I want you to do that because you will see why as we move on. Okay. So in other words, I want you to, instead of saying 2p2, that's what you want. Okay. I would rather want you to place them in those suborbitals. Okay. Now, what you need to know is, whenever you have, let me go back to this. Whenever you have electrons to be distributed among a set of orbitals, if those set of orbitals have the same energy, what you need to do, you make sure that each one of those orbitals gets 1 electron before you fill up any suborbital. In this case, notice what we've done. We place 1 electron here on this orbital here, and 1 electron here on this orbital here, and nothing here. You do not place both of them here. You don't do that. That is a no-no. Okay, you don't do that. Okay, because these p orbitals here, because they have the same energy, that is what we refer to as being degenerate. Meaning that they have the same energy. All of these, they have the same energy. Okay, so when you have degenerate orbitals, what to do before you fill up any particular orbital, you make sure that at least all of them get 1 electron each. Okay. Okay. So let me see here. I think let me go back to this. Now, let us stay with this. I will go back to that electronic configuration. We start with a carbon atom. It has 6 electrons. We distributed all of the 6 electrons here, 2 here, 2 in the S, and then 1 in the PX, 1 in the PY, and none in the PZ. Okay. This here, those electrons that you find in the energy shell, in the last energy shell that contains electrons, which is this, the p orbitals, we refer to this as the valence orbitals. Valence shell. And the orbitals in the valence shell, we say they are valence orbitals. So the valence shell is the last energy shell that contains electrons. Okay? The valence shell is the last energy shell that contains electrons. And the number of electrons in the valence shell we refer to as the valence electrons. Okay? Refer to as the valence electrons. So if I ask you, how many valence electrons does carbon have? 4. No, it's not time yet. It's time. Okay, let me very quickly finish up this here. Okay, so therefore, I ask you for the electronic configuration of carbon. You say it's 1s2, 2s2, 2px1, 2py1. Okay, and that is the ground state electronic configuration of carbon. So when we come back on Thursday, we are going to take off from there. Okay, so I will see you on Thursday, and these are the recording of this lecture. Today's lecture will be posted in Blackboard by tomorrow. Yes.